And hello mathematicians, I'm here to describe and provide you with an example of the relationship between a circle and the area of a circle and the polygon that is inside a circle. And we're doing this in support of our project on tessellations ultimately, and related to the beehive question and video that you've watched already as part of this project. So what we see here is a triangle, and the mathematical word we use here is inscribed, which means that the triangle actually has the 3 points of the vertices on the circumference of the circle. And what you see here is just a couple of measurements. That we have a circle with centre 0, so it's got a radius of 6. And we know that the area of the circle is pi r squared, and so pi times 6 squared is 113. The circle also has a circumference of 37.7, and that is 2 pi r to get that calculation. The triangle, as you can see, has an area of only 46 units, and the perimeter of the triangle is 31.18. Okay, so what we're going to look at is this little thing up here is going to give me n means the number of sides of this polygon. Now, a polygon, don't forget, is a straight-edged, enclosed shape. So 3 sides is the smallest polygon you can have. And what I'm going to do is just drag that up by a fraction. And the next polygon we have is called a square, as you would know. Now, let's go back to 3 and watch these numbers here. The area of the circle, of course, and the circumference won't change because I'm not changing the shape of the circle at all. But if I go back to the triangle, I've got an area of 46 and a perimeter of 31. Whoops. Now I've got a much bigger area and a bigger perimeter. Now, why did the area get bigger? Well, because I'm using more of the circle. Let's go back again. See all this area here? All this area in these blank bits here is not part of this triangle. But when I go up a fraction, now I've got these 4 parts which are not used, but there's less area being wasted, if you want to think of it like that. If I cut this square out of this circle, I'd have less wasted paper. So the area's gone up and the perimeter has also gone up. I'm going to go up by 1 more. Okay, and again what you see is the area is getting bigger and the perimeter is getting bigger. Now, have a think about this. As I start dragging n all the way up here, what's going to happen with the area? Is it going to get as big as 113? Is it going to get bigger than 113? Is the circumference going to keep getting bigger? Sorry, the perimeter of this thing going to keep getting bigger and bigger? Is it going to get bigger than 37.7, or is it going to stay below? Now let's have an exploration. 85.6 and 30. So let's say 85.35. Let's go back to 6. It's gone from 85 to that, and 35 to 36. Now, why is the area getting bigger? Again, because although I've now got all these little cut bit out, this is little. It's smaller wastage than the original triangle. And what shape have we got here now? We've got the hexagon, and this is what we looked at in the bees problem. So what you can see is that the area is pretty good. If I use a hexagon instead of a circle, look, I'm 20 units below, right? But it's not so bad. Now, I'm going to start drifting upwards now, and you watch what's happening. What shape am I ending up here? Now, without counting the sides, there's 10, so it's a decahedron. I'm going to keep going. What do you see about the shape of the polygon compared to the circle? Well, the more sides I have of the polygon, the closer it looks to be a circle. And watch this. Now, can you see the sides of the circle? And I think it goes up to 100. There you go. Now, what's happened here? The area of the polygon now is almost the same as a circle because there's such little wastage between each point, right? And the circumference is almost the same. The perimeter, I should say, is almost the same as the circumference. So the more sides you have of a polygon, the more like it is a circle. Now, of course, if you were a bee and you were going to create, you wouldn't probably be creating a 100-sided polygon. And really the question was, in the video, it said 6. Why was 6? Well, the fact is that 6 isn't necessarily the best for bees. It just happens to be what they use. But they could have used an 8. They could have used a 10. It's just a bit more work in getting that structure. And you can investigate that further if you'd like. The last thing I want to do is move this out, say, to 50. Okay, now you can't see any difference with the circle and the polygon now, and certainly not at this level. Now what I'm going to do as a very last thing is I'm going to show to you that although there's even only a tiny bit of gap, let's have a look at the gap. And what we're going to do is scroll in right as far as we can until I lose this picture. And what I'm doing is increasing the size. Now it looks like those two things are on the same line, right? Okay, here we go. Any second now. And what we see, and you can only just see it, right? Right. That blue bit is the circle. This pink bit is the polygon, the 100-sided polygon. And there, if you can see it, is just the gap, that little white gap between the polygon and the circle. And that's why, going back to the area here, we have such little wastage now that you couldn't even cut that off with a pair of scissors, right? So as you get a bigger and bigger number of sides on a polygon, it becomes more and more like a circle. And that's what I wanted to demonstrate in this short video. So there you go. I hope you've enjoyed that explanation.